Good morning. Today we look at paper 1 multiple choice May-June 2019 paper 12. Let's look at question 1. Now the Boltzmann distribution of molecular energies in a sample of aqueous hydrogen peroxide at the room temperature is shown. Okay. Now this curve is without catalyst because the catalyst for this reaction is manganese 4 oxide. Now which diagram shows the Boltzmann distribution of molecular energies of aqueous hydrogen peroxide maintained at room temperature when a catalyst manganese 4 oxide is added. Now with catalyst, right, we know the activation energy is lower. Now the shape of the curve will not change, right? Okay, so it's still maintained, but this time with a lower activation energy. Okay, that's why the answer is B. Number 2. Oxygen has 3 stable isotopes, 16 oxygen, 17 oxygen, and 18 oxygen. Now, all 3 isotopes are present in a sample of oxygen gas, O2, which was analyzed using a mass spectrometer. Now, how many peaks associated with O2? Right, the molecular ion. Alright, now, so that means in this O2, there will be a combination of 2 isotopes. Right? So it can be either 16, 16, 16, 17, 17, 17, 17, 18, or 18, 18, right? Okay. So I also calculate the molecular mass of the ion, 32, 33, 34, right? And 35 and 36. So altogether there will be 1, 2, 3, 4, 5. Question 3. The first 8 successive ionization energies for 2 elements of period 3 of the periodic table are shown in the graphs. Okay, the first graph shows a jump between the 7 and the 8. Okay, and this element most probably belong to group 17. And the second graph shows the jump of ionization energy occurs between the second and the third, right? So these elements belong to group 2. Now, which is the formula of the ionic compound formed from this element? Right, okay, so this one will form the 2 plus, okay, 2 plus ion, that means most probably in period 3 that will be magnesium, right? Okay, and this is group 17, so in period 3 most probably will be chlorine, right? Okay, so that's why the answer is magnesium chloride. Okay. Question 4. A sigma bond is made between 2 carbon atoms in a molecule of ethene. Which diagram shows the orbital overlap that occurs to form this bond? Okay, now the sigma usually overlaps ends on, right? Well, the pi bond overlaps sideways. Now this is a pi bond, right? And since carbon-carbon, right, involve the hybridization of sp2, right? And this is a hybridized orbital, right? So this one you can see from A is usually between hydrogen, this one between hydrogen-carbon, and this one between carbon and carbon, right? Okay, so since they're asking for 2 carbon atoms, right, so the answer would be C. Number 5, which substance could be potassium iodide? Okay, potassium iodide is a giant ionic structure, so with high melting point and able to conduct electricity in molten or aqueous state, right? So we choose between C and D because this one will show a high melting point, right? Okay, but we also have to look at the electrical conductivity. When molten should be a good conductor, that's why we choose C, right? And number 6, sorry, X, Y, and Z are all gases that behave ideally and react according to the equation shown. When 3 mole of X and 3 mole of Y are placed inside a container with a volume of 1 dm3, they react to form the maximum amount of Z. So the final temperature of the reaction vessel is 120 degrees. So what's the final pressure inside the reaction vessel? Right, okay. So I have 3 mole of X and 3 mole of Y initially, and 0 mole of Z. So okay, so at the end of the reaction, okay, so before that we have to determine which is the SS, which is the limiting reactant, right? Okay, so we know this is a limiting reactant, right? Okay, because 3 divided by 2 give 1.5, 3 divided by 1 is 3. This is a smaller one, right? So limiting reactant. So we know that Y will be used up in the reaction, 0, right? Okay, if 3 mole reacted, so there will be 1.5 mole of X reacted, right? So the balance is 1.5, and based on the ratio, you can also determine the mole of the product, which is also 3 mole, right? Okay, now that means the total mole at the end of the reaction is 4.5, okay? So if you use PV equal to nRT, right? So we want to find the final pressure. So the volume is 1 dm3, okay? And this is 4.5 mole, and R 8.31, and temperature is 120 plus 273, so you get 393. So you should be able to get the pressure here. Number 7, which pair of substances are both simple molecular? Right, okay, C60, okay, is buckyball is simple molecular structure, well, graphene is a giant covalent, okay, simple, and iodine simple, graphene giant, and here also giant, graphite also giant, iodine is simple, so they want both simple, so the answer is B. Number 8, a reaction pathway diagram is shown. Which row is correct? Enthalpy change is always the difference between the reactant and product, okay? So it's K, because it's going down, so the arrow should be going down, okay? And the activation energy is always the energy that you need to overcome, right? So imagine you are here, so you want to go to the other side, so this is the barrier of energy that you need to overcome, right? Okay, but for the reverse reactions, right? Okay, so the barrier of energy that you need to overcome will be O. Okay, for the forward will be M. Right, okay, so since they're asking for activation energy of the reverse reactions, right? So the barrier of energy that you need to overcome is O, because you are, imagine you are here, you need to go to the other side. Okay, go back to the reactant, so you need to jump that high, O. Okay, number 9. X is either chlorine or an oxide of chlorine. X react with water under suitable condition to form two acids, hydrochloric acid and hypochloric acid. Chlorous acid. Sorry, this is okay. HClO3. Okay, okay. Forgotten how to name it. In the mole ratio of 1 to 5. Right. So what could X be? Okay. So since we have this product form, okay, the oxidation state is -1, this is +5, okay, the oxidation state, and we know the ratio is 1 to 5, that means there will be 5 HClO3, okay, okay, so that means the best state to suit the change in the oxidation state for both elements, right? Okay, so that means you want to, okay, to have 5, you have to be difference by 1 unit. Okay, so that's why we choose +4. I can show you here, right, how it occurs, right? 4 to 5, 1 unit, and 4 to -1, 5 unit. Okay, 5 times 1, change of 1 unit. Then number 10, ethyl ethanoate. undergoes the following reaction. Equal amount of ethanol acid and ethanol will mix and allow to reach equilibrium. So at equilibrium, the concentration of both ethanol acid and ethanol were 0.42 mol per dm cube. What's the concentration of ethanol at equilibrium? Okay. Okay, now if let's say we flip the equation, right? Okay, we flip the equation. Now your Kc value will be 1 over 0.27. Okay. Okay, let's calculate the equilibrium constant, right? Okay, so assuming the concentration of ethanol is Y, right? Okay, and the equilibrium concentration for both ethanol acid and ethanol was 0.42, right? So you substitute the Kc value and you determine the Y, that will give you 0.81. Okay, now let's move on to question 11. Which role is an example of heterogeneous catalysis? Okay, so esterification with sulfuric acid. Now this is homogeneous, right? Contact process, okay, involving the reaction between sulfur dioxide and oxygen gas, but with the catalyst of vanadium oxide, which is a solid. So this is a heterogeneous catalysis. Okay, and for C, both of them are in the gaseous form, and for D, also both of them are in the gaseous form, right? So all these are homogeneous. Question 12. Element Q readily oxidized in air. The oxide produced react with water to form a solution of a very low pH. Now, where could element Q be found in the periodic table? Okay, so assuming okay, the oxide of the element Q, should be Q here, right? Add water, right? You form a very acidic solution, right? Low pH. Okay, that means this shows that the element Q is a non-metal. Okay, non-metal here. Right? Okay. So we choose a non-metal. The non-metal could be either okay, carbon, silicon, and phosphorus, right? Okay, and then we look at the acid solution that are formed by this element here, right? Okay, group 40 in period 2 is carbon, right? Which is carbon, okay, they form carbon dioxide, and if you dissolve in water, they form carbonic acid. Now, this is the weak acid, okay, not very low pH. Then silicon dioxide, okay, okay, silicon dioxide does not dissolve in water, okay, so this is actually not oxidized, not soluble, okay, error here, not soluble. And then for D, P, phosphorus will oxidize to P4O10, and then when they dissolve in water, they form phosphoric acid. Now this is a solution with a very low pH, right, between 1 to 2. Okay, so that's why the answer is D. Now 13. The 8 elements sodium to argon are in the same period of the periodic table. The equation corresponding to the first equation energy is shown. For which of these 8 elements is the electron in this question removed from a fuel orbital? Right, okay, fuel orbital means now we focus on the orbital, not subshell, right? Okay, so a fuel orbital will contains a pair electron, whereas not fuel orbital will only contain maybe like a 1 unpaired electron or even no electron at all. Okay, so I put down, right, phosphorus, silicon, sulfur, chlorine, argon, right? Okay, so the one that you remove from the field orbital will be sulfur. Okay, so you have to remove from the pair first, and then chlorine, and also argon, and also this magnesium, right? These are all from the pair electron, except phosphorus and silicon. 14. Elements D and E are both in period 3. Element D has the smallest atomic radius in the period 3. Okay, so I show here. Okay, chlorine will have the smallest. There are only two elements in period 3 which have a lower melting point than element E, right? Okay. Okay, so for melting point, period 3, I should draw the graph, okay? And this is the phosphorus, right? Okay, beside phosphorus, there are two more elements that have lower melting point, chlorine and argon, than the phosphorus. Okay, so we identify that the element will be phosphorus and chlorine. Okay, so the best compound will be D. Now 15, how many of the solutions shown when added to separate portion of magnesium sulfate solution produce a white precipitate? Okay, so you're going to add with magnesium sulfate or each of these solution. Now when you add HCl to magnesium sulfate, okay, you get magnesium chloride. Okay, it's not a precipitate. Okay, but when you add magnesium sulfate to ammonia, right, you get magnesium hydroxide, which is a white solid. Okay, so you form a precipitate. With ammonium carbonate, you form magnesium carbonate, also a precipitate, and barium nitrate. With magnesium sulfate, you form barium sulfate, is also a precipitate. So they are all together 3 solutions. Now 16, a white solid Z is soluble in water. A sample of Z is heated with a Bunsen burner until there is no further change. When the residue is shaken with water, a solution is formed with no solid remaining. Now what could Z be? Okay, it's insoluble in water. Okay, so I already identified which compound is soluble, which compound is insoluble, right? Okay, so nitrate soluble, right? So there are 2 compounds that are insoluble. Okay, but they want soluble, right? So that means answer could be either B or D. But you have to heat with Bunsen burner. Okay, so when you heat with Bunsen burner, you get magnesium oxide, and this one you get barium oxide. Okay, and then you shake with water. Okay, you find that this one insoluble. Magnesium oxide is insoluble in water, whereas barium oxide is soluble to form barium hydroxide, right? Okay, so that's why the answer will be D. 17. An excess of chlorine was bubbled into 100 cm cube of hot 6 mol per dm cube of sodium hydroxide. How many moles of sodium chloride will be produced in this reaction? Okay, so this is a reaction, right? Chlorine with sodium hydroxide, hot, right? So you get sodium chloride 5. Okay. Then we find the mole of sodium hydroxide, 0.60. Okay, and we get the relationship between the sodium chloride and the sodium hydroxide. Okay, the ratio is 5/6. Okay, so since we know the mole of NaOH, okay, so you multiply, you get mole of sodium chloride is 0.50. 18. Ammonium sulfate and ammonium nitrate are used as fertilizer. Okay, now these sort have different percentages by mass of nitrogen. They have the same effect as each other on the pH of a wet neutral soil. Okay, so between these 2 compound, right? Okay, so ammonium nitrate will have a higher percentage of nitrogen, right? Okay, so we choose ammonium nitrate. Okay, because we know that if that both of them have two nitrogen, but the MR of ammonium sulfate is much bigger, so that's why the percentage will be lower. Okay, and the effect of the pH of the soil. Ammonium compound is actually acidic because they have excess hydrogen to be donated, right? So that's why if you add into the soil, you will cause the soil pH to drop. Okay, that's why the use of excess fertilizer will make the soil acidic. 19. Which reaction give a product that is an atmospheric pollutant causing acid rain? Okay, acid rain. Acid rain in the atmosphere is caused by SO2 and SO3 because both of them actually dissolve in the rainwater to form a very strong acid, especially sulfuric acid. Okay, from the SO3. Okay, 20. We should correctly identify the reaction type. Okay, from reaction 1, okay, there's a the double bond disappear, means hydrogenation take place, so you need a hydrogen gas, right, which is a reduction process. And in the second reaction is you add Cl2, right, there's an electrophilic addition, right. Okay, so the reaction 2 will be electrophilic addition. 21. Compound X does not show cis trans. Okay, what could be the identity of compound X? Okay, so I draw roughly the structure, right? Okay, Cl 1 1 2 1 1 2. Okay, and propane. Okay, okay. I think there's a this is a wrong structure, right? The double bond is supposed to be here, right? Okay, supposed to be here. Okay, supposed to be here. Okay, the double bond. Okay, and of course you put double bond here, the hydrogen here is removed. Okay, okay, but if when you put here, there will be no cis trans because there will be two Cl here, alright. Okay, the second one, 1 2 3 trichloropropene, right? Okay, so I already draw the structure. Okay, so this is 1 chlorine, 2 the second carbon, and third. Okay, so again this one shows cis trans. Okay, then for C also I draw the same another the compound. Okay, so this one. Okay, okay, so again this one also shows cis trans. Okay, similarly I should also draw for D, also shows cis trans. Okay, except A that you shift the double bond to this side. Okay, to this side. Okay, 22. What is the correct name of the monomer that would form this polymer? Okay, so we put back the double bond inside. Okay, and then remove the link. Okay, the line at the carbon. Alright, so to name this compound, okay, so we try to label the carbon, okay, and the purpose is to give the lowest numbering for the double bond. Okay, so in this case, okay, the longest chain is 3. Okay, you will count from the longest chain. This is the longest chain. Right, this is a third carbon. Okay, so it's a hex 3A. Right, and this is a trans. Okay, trans. Okay, and these two substituent is at the third, third, and fourth carbon. Okay, 23. A molecule of geranium is shown. What is formed when geranium is reacted with an excess of cold dilute acidified potassium manganate ion? Right, okay, so you form diol, right? So both the double bond, okay? So you're going to add 2OH. 24. Alcohol W cannot be made by reducing carboxylic acid with lithium aluminum hydride. Alcohol W gives only one product when dehydrated with concentrated sulfuric acid. Now, what could be the identity of W? Okay. Okay, so you cannot reduce the carboxylic acid with lithium aluminum hydride. That means, right? Okay. And only give one product when dehydrated with concentrated sulfuric acid. Okay, so assume these are the options. Okay, so assuming I'm going to dehydrate it. Okay, so this alcohol you form this one you form two product, this one you form one product, and the last one also form one product. Okay, so we rule out B already. B cannot because you get two product. And we know alcohol cannot be reduced the carboxylic acid. Carboxylic acid is formed by a primary alcohol. Right, so only primary alcohol can be reduced to carboxylic acid. Can be obtained by reducing carboxylic acid. Okay, so again we remove A and C because this one can be obtained by reducing carboxylic acid. Now this one cannot be obtained by reducing carboxylic acid. Okay, ketone cannot be obtained from carboxylic acid. I mean the secondary alcohol, sorry. Secondary alcohol is obtained from ketone, not carboxylic acid. 25. Which product can be made from bromoethane by an elimination reaction, right? So this one you remove a molecule out of the compound, right? So bromoethane, if you remove a molecule, like in this case HBr, you'll form ethane, right? 26. Propene, bromine, and hydrogen bromide are mixed in the dark. A number of products are formed, some in a very small quantity. Now, which substance will not be present in the mixture of the product? Okay, so there is propene can react with bromine to form this compound, and also can react with hydrogen bromide to form this compound, right? These two compounds. Okay, so you say which substance will not be present? Okay, one bromo. Okay, we have one bromo. Two bromo, we also have. One dibromo, we don't have. One two dibromo, yes, we have here, right? So that's why the answer is C. Which reagent could be used to distinguish between ethanol and propanol? Right. The best is to use triiodomethane because one of them have the structure. Because triiodomethane you must have a methyl carbonyl, right? Okay. So the ethanol have methyl carbonyl, but propanol doesn't have the structure. Okay. So the rest of the option is not correct. Okay, and I already justified. Both are oxidized. Both are aldehyde. Okay, they are oxidized. Tolerance also both will show the same result. 2,4-DNPH both will also show the same result. 28. Now this diagram shows that a carboxylic acid may be found from X, Y, and Z. Okay, so we look. Okay, if it's a carboxylic acid, we know it's primary alcohol. Okay. Alright, so now let's try out with one compound, right? Okay, so if we try out with ethane nitrile, so you get ethanol acid. So this one will be ethanol, and this will be ethanol. Okay, so Definitely alcohol X is primary alcohol. And then we calculate the mass. Okay, it's 26, 45, 29, 31. Okay, so which one will cause the greatest change? Okay, of mass, right? So is it Y to P? You can see the difference lah, right? 16. Or is it Z to P, right? Z to P is 19. Okay, the difference, right? That's why the greatest here will be Z to P. Now 21. One molecule of compound R is shown. What is the name of compound R, right? And how does the boiling point compare with that of butanoic acid? All right, now this is the ester, right? Okay, so the name, this is come from methanoic acid, and this one come from the alcohol part. All right, that's why when we name, we call propyl methanoic. Okay, and ester will form a permanent dipo-dipo interaction. Well, this one will form hydrogen bond, right? Of course, butanoic acid will have a higher boiling point than the R. Okay, so in other words, R is lower than butanoic acid. Question 30. Now, what could be Q? Okay, this one caused by carbon hydrogen, this one caused by carbonyl at 1700. So, so the best answer would be C. 31. When oxygen gas react with hydrogen sulfide, the product are SO2 and water. Mixture Y contains an equal number of two molecules shown and no other molecule. Alright. Okay. So let's see. The first one, the average relative molecular mass in Y. Okay, so Y, this one 34, this one also 34, correct. If some oxygen molecule are removed from Y, the average amount of the molecule remains the same. Yes, even though you remove the oxygen O2, the average or the relative molecular mass remain the same because both are 34. When mixture Y is ignited, some H2S remain unreacted. Okay, the oxygen will be used to probably react with the H2S. Okay. Okay, and we know that oxygen will be used up in the combustion. Okay, because if you write down the equation, right? Okay. Okay, so you need more mole of oxygen gas. Okay, so this oxygen gas, okay, since you're given equal number, right? So the oxygen will be definitely used up. Okay, 32. Which statement about an atom of 99 Tc are correct? Okay, so this one you get it from the data booklet. So we know that there are 43 protons, right? So the number of neutrons we can calculate, which is 56. Okay, so yes, 13 fewer proton than neutron. Yes, okay, the difference here is 13. It form the ion with 2 positive, which has 45 electron. Okay, so it's wrong. So by right should be 41 electron. Okay, so because the atom itself is 43 electrons, so if you lose 2 electrons, it's 41. So it has 56 nucleon. Okay, nucleon means referred to proton and neutron together, right? So actually we only have 56 neutron, not nucleons. And the 33, in which reaction are nitrogen atoms reduced? Okay, so you have to calculate the oxidation state, like 4 to 0. Okay, so there's a reduction. 4 to 1 also reduction. 4 to -3 also another reduction. 34. The manufacture of ammonia from nitrogen and hydrogen is an important industrial process. Now, which of the following would leave the equilibrium constant Kp for the formation of ammonia unchanged, right? Okay, so Kb we know only affected by temperature. So any changes in catalyst or product or reactants will not affect, right? even in the increase of pressure, will also not affect the Kp. 35. Which reaction involving calcium and its compound produce two gaseous product? Okay, so calcium nitrate. Okay, so you get two gaseous product, NO2 and oxygen. Carbonate, calcium carbonate, only one gaseous product. Okay, and this one also one gaseous product. 36. A small quantity of hot concentrated sulfuric acid is added separately to solid sample of potassium halide. Now, which potassium halide react and produce a mixture product that include a halogen X2? Right? Okay, so we know chloride cannot reduce sulfuric acid. This is a weak reducing agent. So whereas iodide and bromide can reduce the sulfuric acid. Okay, and iodide itself can be oxidized to iodine. Bromide also can be oxidized to bromine. 37. The diagram shows a compound used as a flame retardant, right? Okay, so which statement about this structure are correct? Okay, so in this case, we have to determine the molecular formula, which is C12H18Br2, and then we simplify to get empirical formula. Okay, so it matches the first statement. C16 ring is not planar, right? Okay, correct. Okay. There are 6 chiral carbon atoms, right? So I circle 1, 2, 3, 4, 5, 6. Okay, so there will be 6 chiral carbon atoms. 38. Halogenal alkanes can be hydrolyzed using aqueous sodium hydroxide. Now, which compounds tend to be hydrolyzed by SN1 mechanism? SN1 usually involves tertiary haloalkane. Alright, so what we do is we determine which compound is tertiary. Alright, so the first and second compound, whilst the third compound is considered primary. Right? And 39, in an organic synthesis, a 62% yield of product is achieved. Now, which conversions are consistent with this information? Okay, I think we calculate the MR of butan 2-ol, butan 1-ol, and 2-methyl propanol. Okay, and also the butanol, butanoic acid, and 2-methyl propanoic acid. Okay, they are isomer. They should have the same mass, right? 1, 2, 3 here. Okay. Okay, so what we do is 74 over 74. Okay, 74 over the MR 74 times butanol 72, right? And the efficiency is 62%, 0.62, so you get 44.64, correct? And the second one also divided by the MR 74 times 88 times 0.62, so you get 54.56, also correct. The third one also 74 divided by 74, okay, times this is isomer butanoic acid divided by times 88 times 0.62, you get 54.56. Okay, also correct. The last question, an oxidizing agent that can oxidize ethanol to ethanoic acid or ethanoic ions will also oxidize methanoic acid to carbon dioxide and water. Which reagent or heating will react differently? Okay, and this methanoic acid can be further oxidized to carbon dioxide and water by either by ferric or manganese. Okay, this one, ethanoic acid cannot be oxidized, but methanoic acid, okay, can be further oxidized to CO2 and water. So reagent 2 and 3. Right, that's all for today. Thank you.